Self-trust is the first secret of success. Good morning to all. Continuing chapter friction. Last video you have learned about friction, types of friction, factors affecting the friction. Types of friction are static friction, sliding friction and rolling friction. Static friction exerts strongest frictional force, whereas rolling friction exerts least frictional force. Today's class we will be learning about fluid friction, increasing friction and decreasing friction. It is not only the ground which offers force of friction on the body moving along its surface. Even water and air exert frictional force. Water and air are fluids. Fluids exert a force of friction on the objects in motion through them. The force that tries to slow down objects when they move through a liquid or a gas is known as drag. An airplane and a swimmer both experience fluid friction. Frictional force from water or liquids. This frictional force depends upon the nature of the medium through which the object is moving. The medium can either be glycerin, syrup or water. The frictional force exerted by water is different from that of glycerin, syrup or any type of liquid. Thinner the medium, then you have less force of friction. Thicker the medium, you have more force of friction. When the object moves through water, it pushes the water out of the way and the water moves over the object's sides and pushes back on the object. This push on the object is also called water resistance or drag. Boats and ships move through water, come across force of friction. This frictional force in water depends upon the shape of the object and the speed with which it moves. Usually the boats and ships are narrow in front and sloping towards the edges. Sides, towards the sides. This is known as streamline shape. These are designed in a special way so that it reduces friction from fluid medium through which these objects move. When an object moves through the air, it pushes the air out of the way and the air moves over the object's sides and pushes back on the object. This push on the object is called air resistance or drag. Airships flying through air face force of friction. Since airplanes move faster, the force of friction between them and the air is very high. Hence, they have a special shape which are called as streamline shape. The jets in supersonics are fast speed airplanes. While flying, these airplanes gets heated up on the surface due to friction. The inside of the plane is insulated to protect the passengers from heat generated on the surface. Friction from air on a meteor. Meteor are the chunks of matter present in the space. When they come in contact with Earth's atmosphere, they are completely burnt up, which are seen to us in the form of shooting stars or falling stars. The speed of this meteor is so high that due to friction it catches fire in the Earth's atmosphere. This generates heat and it appears like a star with a tail, which is also called as shooting star or falling star. The spaceships. Spaceships are sent to space with the help of rockets which generate a very high speed. Due to this high speed, a great frictional force comes into play between the spaceship and the air. The frictional force is so high that the spaceship gets heated to red hot while passing through the air in the atmosphere. To overcome heat, fire-resistant tiles are laid along the surface of the ships, especially the manned ships. I think you must have heard about this Columbia and American Space Shuttle. It was a shuttle which carried Kalpana Chawla and 6 others on a space mission. It got burnt up in the atmosphere with just 16 minutes to go before landing due to leakage in its protective outer shield. As a result, all the astronauts lost their lives. This is one of the tragic incident. So our heartfelt homage to them. Increasing friction. Parachutes are designed to increase friction. Air friction slows down the parachutes of a falling man so that he can land safely. The tread of a car tire is designed to move water out of the way as tire rolls on a wet road, reducing the risk of sliding. Racing cars have smooth tire which is ideal for a dry track. If it rains, they slide and skid all over the place and the tire need to be changed. The friction between two surfaces can be increased by pressing the surfaces together more strongly. You can see scrubbing, washing utensils, scrubbing a board with a sandpaper to make it smooth. This makes the projection press against each other more strongly and increases the size and number of connections between the surfaces. When brakes are applied to a bicycle or a car, the brake pads press against the moving part of the wheel and the force of friction increases. This opposes the rotation of the wheel and slows down the bicycle or car until it stops. Reducing friction. How to reduce friction? Friction, we all know that friction is due to roughness of surfaces. Smooth surfaces exert little friction. So, it is evident that to reduce friction, the surfaces must be made smooth. Streamlined shapes. Boats, cars, planes and rockets have special shape to reduce friction with water or air, which is called as streamlined shapes. A car's body is designed like a wedge to cut its way through the air, and the surfaces are curved to allow the air flow over the sides with a minimum drag. Polishing. Polishing reduces the unevenness of the surfaces. Polished jewels are used in watches to hold axle between them. The same can be achieved by rubbing the surfaces with the sandpaper. A slide in the park is polished smooth so that you can slide down easily. Separation of surfaces. We can separate the surfaces by air to reduce friction. A good example is hovercraft, a vehicle that moves above water or land by gliding on a cushion of air. It is created by blowing downward. A hovercraft moves on a layer of air between its hull and the water. The layer of air reduces friction, allowing a hovercraft to move easily. Lubrication. Lubrication reduces friction. When we apply some lubricants to surfaces, a thin layer of lubricant is formed and moving surfaces do not directly rub against each other. Oiling of machines, greasing of fans, etc. are the normal routine for less wear and tear of these things, and along with that you can save energy. Solid lubricants like carom powder is used to smoothen the surface so that the strikers move from one place to another easily. Using ball bearings. Ball bearings are small metal balls which are used between sliding surfaces in machines, which will convert sliding friction to rolling friction. They are fitted in the wheels of the bicycle to reduce friction and saves a lot of energy. I hope you have understood today's class. Make a note of all the points in the classwork. You have a small activity to do. Take a sheet of paper and hold it flat at some height. Now let the paper fall and note down the time it takes to reach the ground. Ensure that there is no air currents while conducting this activity. Again, take the same sheet of paper and crumble it into a small lump and allow it to fall from the same height. Note the time taken to reach the ground. Compare and draw conclusion. Thank you, children.
Does friction exist only between solid parts? Not necessarily. Friction is offered by fluids like air and water as well. And this force of friction due to fluids is referred to as the fluid friction. The friction we've seen between solid parts is referred to as dry friction. The major states of matter are solid, liquid and gas. And liquids and gases are generally referred to as fluids. Why are liquids and gases considered to be fluids? One common characteristic of fluids is that they have no fixed shape and can be easily deformed. Let's discuss a bit more about fluid friction in this lesson. Just like solids, fluids too exert a force of friction when objects move through them. Do you think air offers resistance? Doesn't seem intuitive, right? When I drop a stone from a particular height, it falls to the ground. Does air offer resistance here? Of course it does. What about water? Does it offer resistance? Yes, when the fish swim, they encounter fluid resistance from the water. The frictional force exerted by fluids is also referred to as drag. What does fluid friction depend on? Let's talk about the first obvious factor. It's the nature of the fluid. To understand this point, you just need to answer a simple question. An object moves from point A to B through air, and in the second case, a similar object travels from A to B through water. Which object do you think encounters more resistance? Clearly, it will be the water, right? Yes, more the thickness of the fluid, greater will be the frictional force acting on an object which moves through it. There's a term which describes a fluid's resistance to flow. It's called viscosity. So here we can say that the water is more viscous than air. Higher the viscosity, more will be the resistance offered by that fluid. Honey is more viscous than water, which is why it offers more friction than water. That was the first factor affecting fluid friction, the nature of the fluid. Can you think of any other factor? Another factor is the speed with which the object is traveling. Higher the speed of the object moving through a fluid, greater will be the frictional force acting on it. A vehicle traveling at 100 miles per hour will face more drag of air as compared to a similar vehicle traveling at 50 miles per hour. Apart from the nature of the fluid and the speed with which the object is traveling, is there any other factor on which fluid friction depends on? Yes, it also depends on the shape of the object. And it's really important that we understand this factor well. Have you ever thought about why aeroplanes are shaped like this? It could just have been a rectangular box flying in the air. How have the fish evolved to be shaped like this? Why are the ships designed to be given this shape? There's a reason for all this. They're given a streamlined shape to minimize the fluid friction. The shape of the aeroplane, if you notice, is like that of a bird. This process of giving an object a particular shape to decrease the fluid friction is known as streamlining. Streamlining the object can greatly reduce the resistance offered by the fluid. A car faces lesser friction from air as it has a streamlined shape. A bus, on the other hand, will face more air friction as it doesn't have a streamlined shape. So these were the different factors on which fluid friction depends. Nature of the fluid, the speed of the object flowing through the fluid, and the shape of the object.
Ways to increase friction. Objective: to understand the different ways by which we can increase friction. Friction enables us to hold things, to walk, and to run. Even a simple action like the ignition of matchstick requires friction. So whenever friction is helpful, we try to increase it for its various advantages. Let us understand this with the help of a few examples. We see that the tires of a car have different patterns on them. These are known as grooves. The grooves help in increasing the friction between the road and the tire. They help the tires get a better grip on the road, and this prevents the tire from slipping on the wet roads. Sports person uses shoes with spikes to increase the friction between the shoes and the ground. The spikes help the shoes to get a firm grip on the ground, and this helps in easy forward motion as the athlete pushes the ground backward. Here is a carpenter sanding a piece of wood to give it a smooth finish. While sanding, he presses down hard on the wood by applying force. Due to the additional weight on applying pressure, the interlocking of irregularities between the sandpaper and the wood increases, which leads to an increase in the friction. As a result, the hard surface of the wood becomes smoother. To summarize, we can increase frictional force by increasing the roughness of the contact surface and increasing the pressure on the contact surface.
Friction as an opposing force causes much wastage of energy. Let us explore some ways to reduce friction through this activity. Here, we have taken a solid wooden box placed on a wooden table. The box has been attached to a spring balance by a hook. Pull the box by the spring balance and note down the reading on the balance when the box just begins to move. We see that the balance reads 5 Newton. This is the force of friction between the surface of the box and the floor. Spread some oil on the table and repeat the activity on the oily surface. This time, the balance reads only 2.5 Newton. This is because of the thin, smooth layer of oil formed between the two surfaces. Substances that reduce friction, like oil, are called lubricants. Now place the box on rollers and repeat the activity on a clean wooden surface. The balance only reads 1 Newton this time. Wheels reduce friction as rolling friction is much lesser than sliding friction. Thus, we find that friction between the surfaces can be reduced to some extent with the help of lubricants and with the use of rollers or wheels.